Hi everybody, this is Tim Urdan, author of Statistics in Plain English, and in this video I'm going to run a chi-square test in R. So if you're familiar with R, then this should be pretty straightforward. If you're not familiar with R, I recommend you take a look at another video that I made called Descriptives and Overview of R. So the code is up here in the top left square, and here you can see the green hashtag line. That's just a note to self saying that this is what we're doing here. So the first line in the actual analysis is telling R to select these two variables from the data set that was already loaded. So the two variables, in a chi-square analysis, you want to be using only categorical variables, nominal categorical variables. So I've got two variables. One of them is the dichotomous variable of competitiveness. So these data came from a sample of high school students, about 1,000 of them, and I'm looking at how competitive they are in terms of wanting to do better than other students, wanting to beat other students, that kind of thing. And it was originally measured on a 5-point scale, but then I did a median split on it to make a dichotomous variable out of it. So there's a high competitive group and a low competitive group. And then the other variable is generation, and this refers to first, second, or third generation students. First generation students were born outside of the US and then moved to the US. Second generation students were born in the US to a parent who was born outside of the US and then moved to the US. And third generation students are those who were born in the US to parents who were also born in the US. So let us run this line to select those two variables. And then this line here is just telling R that a variable that had been coded as a continuous variable in the original data file, which was an SPSS data file that was imported into R, that variable needs to be reclassified as a categorical variable for R. So we'll run that. Okay, next here, we are telling SPSS that we want to create a table, a chi-square table, and then this next line down here is to run a chi-square test on that table of selected data. So first we'll run this table line, and we can see what we get down here in the bottom left square is the chi-square table. So in the rows, we've got the low competitiveness group and the high competitiveness group. I just coded that 0, 1, 0 for below the median, 1 for above the median in competitiveness. And then the columns are the generational groups. So third generation, second generation, first generation. And what we can see when we look at this is that third generation, in this third generation column, there's roughly an equal number of students in the low competition and the high competition groups, 150 to 147. So those are pretty equal. In the second generation category, we can see that there are almost twice as many students in the high competition group as the low competition group. And in the first generation column, we can see that difference, that disparity is even bigger. About 2.5 times as many people in the first generation group are in the high competition group as compared to the low competition group. So the numbers from the table don't look like they are spread out evenly across, as you would expect, across the three generational groups, depending on their competitiveness status. It looks like there's a bit of a disparity there between the numbers that you get in each cell, the number of cases in each cell, and how many cases you would expect to be there just by chance. So if we run this chi-square statistic, we can see whether that disparity is significant. And what we see is we get a chi-square value of 25. Whoops. It's right here. A chi-square value of about 25.426 with 2 degrees of freedom. That's the rows minus 1 times the columns minus 1. So 2 minus 1 is 1, 3 minus 1 is 2, 1 times 2 is 2. And the p-value here is 3.012 to the negative 6th. That would be moving this decimal point over 6 places, give you 0.00003, which is well below 0.05 and is therefore statistically significant. So there's other things that you can do in a chi-square. You can also print out the expected values for each cell in the table, this table up here, if you want to, so that you can compare the observed and the expected. But it's not really necessary. If we can sort of just take a look at it, we can see that there seems to be a bit of a disparity there in the way that these numbers of students in the high and low competitiveness groups differed between the generational groups. And then we can see that that difference that we just noticed by looking is a statistically significant difference. So that is how you conduct a chi-square analysis in R.